Welcome to everybody, students, ladies and gents. How are you? We start today a new lesson which is known as magnetic effect of current. বাংলায় বলে তড়িৎ প্রবাহের চৌম্বক ক্রিয়া। এই লেসনটি আমরা আজ জয়েন্ট আইআইটি লেভেলের প্রিলিমিনারি লেভেলের জন্য পড়াশোনা করব। This lesson will be solved in one shot only, and it will be explained to the best of my knowledge and belief as far as lucid possible. My channel name is Vidyut Flow. You may subscribe it. So our first problem is going to be started, which is written as a charged particle is fired from the origin of at an angle theta to a uniform magnetic field directed along the x-axis. If the pitch of the helical path is equal to the maximum distance of the particle from the x-axis, then which of the following are not correct? চারটা অপশন এখানে ছাড়া আছে, তার মধ্যে একটা বা একের অধিক অপশনস রাইট আছে, বাকিগুলো রং আছে। যেগুলো রং সেগুলো আমাদেরকে অ্যান্সার করতে হবে। সো ইট মে বি one or more than one answers. So let us go to the board. How to grab the problem in a lucid manner. Suppose this is x-axis, this is y-axis. So the charged particle is thrown at an angle theta, where here is B. Magnetic field is acting along the x-axis. This is O, this is X, this is Y. So we know the P equals twice pi mv cos theta upon qb, where P is the pitch of the helical path. The path will be in this way, which is known as helical path. This path is known as helical path. The distance, this is twice r. The maximum distance is twice r, because this is circle. This is r, this is r, so twice r. The diameter of the circle. So how this comes, we know from 12th class that pitch, expression for pitch is this. Now to solve the problem, we first deduce the relation. How? We know P equals to V cos theta into T, because here is V, so this is the component along x-axis is equal to V cos theta, and along y-axis equals to V sin theta. So now we know mv square by r equals to qrb, because here is a particle thrown and here is a magnetic field. So force equals to q b cross v. So this is Q, V cross B, and so in this way V cross B particle will take the helical path. And so we write here by taking the modulus, scalar modulus, we get QVB. So QVB. So MV upon R equals to QB. After all, V equals to QRV upon M. Now T equals to twice pi R, this divided by V. So it is a time period of the circular path. In this way you get twice pi R by V. So V by R equals to QB by M. So R by V equals to M by QB. Put here we get twice by M by QB into V cos theta. Now this MV sin theta equals to QR from this. We get MV, here is MV sin theta, so V cross B, we get V cross B in this way, V cross B, so V cross B along the perpendicular direction to the board. So we get from this as R equals to MV sin theta upon QB. So, and for pitch to be maximum, which should be twice R given here. So P twice pi MV cos theta upon QB must equals to 2 into R equals to MV sin theta this divided by QB, implies tan theta equals to pi. So this is the answer which is correct one. And the question said the incorrect answers to be mentioned here. So A, B, C are the answers. So answers A, B and C. Second one is a coil current carrying I has the shape of an equilateral triangle. বাংলায় বলে সমবাহু ত্রিভুজ। সমবাহু ত্রিভুজের আকার বিশিষ্ট একটি পরিবাহী তারের মধ্যে দিয়ে কারেন্ট যাচ্ছে যার পরিমাণ হচ্ছে I. We have to find the magnetic field at the center of the triangle. Suppose this is ABC. Suppose current goes through this direction. This is center. Where is A? Where O is the center point. So we know for the part AB, the magnetic field at O will be obtained as BAB. B for magnetic field B dash for AB portion equals to mu 0 I upon 4 pi D sine of theta 1 plus sine of theta 2. This is the result where I is the current, mu 0 by 4 pi is the constant, which is for precise unit. and D is the perpendicular distance from the wire to the center point. লম্ব দূরত্ব, এই ওয়্যার থেকে লম্ব দূরত্ব হচ্ছে small d, where theta 1 is the angle at one end and theta 2 is the angle at other end. How this expression written here? This expression will be proved, will be deduced at the next problem. Now we take this relation to solve the problem. So here we get OD. Suppose this is D point, so OD. So OD, and this is 30 degree, this is 30 degree, because টোটালটা 60 ডিগ্রি আছে সম্ভবত বলে, সো এটা 30 ডিগ্রি 30 ডিগ্রি বাংলায় যেটা বলে, সুতরাং এটা কত 60 ডিগ্রি হবে, বিকজ এটা 90 ডিগ্রি আছে। সুতরাং দেখতে পাচ্ছি আমরা ওডি আপন বিডি ইকুয়ালস টু tan অফ 30 ডিগ্রি। এখান থেকে পেয়ে যাচ্ছি আমরা ওডি সমান পেয়ে যাচ্ছি ওডি বাই বিডি, বিডি ইকুয়ালস টু L by 2 tan 31 by root 3. So OD equals to L by 2 root 3. So OD equals to L by 2 root 3. Now theta 1 equals to 60 degree, theta 2 also equals to 60 degree. So we get this one as mu 0 I upon 4 pi 2 root 3 upon L into 2 sin 60 equals to mu 0 I root 3 by pi L sin 60 root 3 by 2 equals to mu 0 I upon twice pi L. So B dash obtained as this, because the current flow in the same order for BA, AC and CB. So for BA in vectorial notation we can write, suppose here is a current flowing, suppose there is a point, or at P we have to find B. Suppose at the point here is a, so taking the this is a delta L length, so this vector is delta L vector, this is R vector at point P. So this current I, suppose, so delta L cross R, so for formula delta B, the magnetic field for this portion at point P equals delta B equals to, we know mu 0 by 4 pi I delta L cross R this divided by R cube in a vectorial notation. So delta L cross R, delta L cross R. So the at the to the plane of the, it will enter into the both perpendicularly. So for this and for this same case, for this also, this delta L, this is R, delta L cross R. For this delta L cross R, same একই জিনিসটা ঘুরছে, কর্ক স্ক্রু রুল দিয়ে আমরা পাই, ম্যাক্সওয়েল কর্ক স্ক্রু রুল দিয়ে আমরা ভেক্টর প্রোডাক্টের ডাইরেকশনটা পাই। So after all we can say that the D is correct one, because for the three portions the electric magnetic field is going, the magnetic field lines are penetrating the both perpendicularly. So the magnetic field lines are perpendicular to the plane of the coil. So this is answer D is correct. Answer D is correct. Again, for this we get this, for this also we get this, for this also we get this. So total B dash BACB, total for total coil BACB we get 9 mu 0 I upon twice pi L. So this one also right. So answer A and D. This is the problem. To find the magnetic field at a point P, which is at a perpendicular distance D, for a straight current carrying conductor, current is I, making angles theta 1 and theta 2 at the two ends. একটা স্ট্রেট কন্ডাক্টর আছে, পরিবাহী আছে, এরকম একটা পরিবাহী আছে, স্ট্রেট কন্ডাক্টর, এখানে কারেন্ট যাচ্ছে, আই কারেন্ট পাসিং করছে, আই কারেন্ট ওয়াই হচ্ছে, এখানে কোনো একটা বিন্দুতে একটা ডিস্টেন্স ডি, এখানে এটা হচ্ছে পারপেন্ডিকুলার ডিস্টেন্স, একটা ডিস্টেন্স ডি, বিন্দু পি আছে, এখানে যদি দুটো এন্ড আছে, দুটো এন্ডের মধ্যে থিটা 1, এখানে আছে আর এখানে থিটা 2, suppose this angle is theta 2, and this angle is theta 1. তাহলে দেখাতে হবে পি বিন্দুতে ম্যাগনেটিক ফিল্ডটা কত হচ্ছে। এখানে সাপোজ দিস পয়েন্ট টেকিং পয়েন্ট পি ডি বি এ পি ডি, suppose this point D, so take this point D where is delta L, segment is taken here, so delta L delta L R vector, so the for direction case at delta B will be mu 0 by 4 pi I delta L cross R upon this. So delta L cross R means here is delta L and here is delta L and here is R. So this one is a cross product of vector quantities, so it will go inside the plane of the board perpendicularly. বোর্ডের ভিতরে লম্বভাবে এটা প্রবেশ করবে। কোনটা ডিরেকশন, দিকটা, ভেক্টর প্রোডাক্টের দিকটা। এখানে আমরা দেখতে পাচ্ছি উই ফিল ফর দিস delta B equals to mu 0 upon 4 pi I, this one for delta L, sine of angle between these two vectors at the formula Biot-Savart's law. At formula Biot-Savart's law, suppose this one is at P, so suppose this delta L, so this one is suppose the tangent, so delta L is the tangent, so this angle is taken into the account, mu 0 upon 4 pi I delta L sine alpha upon R square. So this is delta B in the scalar form. So here is also alpha, here suppose this angle is alpha, so alpha equals to 90 plus theta, so sine alpha equals to cos theta, sine of 90 plus theta equals to cos theta. So delta B equals to mu 0 upon 4 pi I delta L cos theta, this divided by R square. Now R upon, now D upon R equals to cos theta. Suppose this angle is theta. So d upon r equals to cos theta. So r equal to d sec theta. So r square equal to d square sec square theta. Again this one is a delta L length segment and this one is a delta L vector. So this one OD length is of L. So there is a element intersection of delta L length. So we can write L by R equals to tan theta, or L equals to R L by D. L by D equals to lambda by bhumi equals to tan theta. So tan theta, so L equals to d tan theta. So delta L equals to, differentiating both sides, we get d sec square theta d theta. So we get delta B equals to mu 0 upon 4 pi I delta L equals d sec square theta. Here is cos theta d theta. This divided by r square means d square sec square theta. So mu 0 I upon 4 pi d cos theta d theta. So B equals to integral delta B equals to integral from, there is a from this, the angle is going into the anti-clockwise direction and this one is the clockwise direction. So this one should be positive, this one should be negative. But for our benefit, this one taking minus and this one taking plus to avoid the negative sign. So we get from minus theta 1 to plus theta 2 equals to mu 0 I upon 4 pi d sin theta minus theta 1 to plus theta 2 equals to mu 0 I upon 4 pi d sin of theta 2 minus of sin of minus theta 1 equals to mu 0 I upon 4 pi d sin of minus theta 1 equals to minus sin theta 1, so minus is a plus, so ultimately we get sin theta 1 plus sin theta 2. This is B in the scalar form. So the previous problem, this was used, which is now deduced in a very lucid manner. A very interesting problem here is a charged particle of unit mass and unit charge moves with velocity v equals to this 8i plus 6j, where I আর j কি আমরা ভালো করে জানি, x অক্ষ বরাবর একক ভেক্টর এবং y অক্ষ বরাবর একক ভেক্টর in a magnetic field of B twice kt. K is the unit vector along z axis and t is the unit of magnetic field in a SI unit in a SI system, which is Tesla. Choose the correct alternative or natives if present here. 4 options given. So let us do our duty. We know F equals to Q V cross B. Q V cross B. Why in the vectorial notation it is written? Because the term in the vectorial notation also there is b is in vectorial notation. Q is 1 given, so we can write 8i plus 6j cross twice k. Unit will be Newton because this one is meter per second and charge is unit charge which is taken at Coulomb unit. Also B is taken in the Tesla unit. So after we get from this triad we can find the sign plus or minus. I cross j will get plus k, I cross j, j cross k, and k cross I will get to plus j. But here is I cross k, so it will be minus j. J cross k will get you j cross k will get to I. So f in modulus form we get minus 16 whole square plus 12 square equals to now mv square by r equals to f because here is x axis, here is y axis. Suppose that this is one is z axis. So here is the vector v is present 8i plus 6j 8i. So the vector suppose this one is vector so suppose this one is vector v and twice k t is here in this direction. So v is in the mind it v is in this direction. Now the position of the problem, v is in this direction and t is b is in this direction twice k t, where b equals to twice kt. So b is in this direction. So v cross b will be v cross b. V cross b will be parallel to this board or parallel to xy plane or in the xy plane. আমি কি বোঝাতে পারলাম? এখানে ভি ভেক্টর আর এখানে বি, এই যে বি ভেক্টরটা along z axis. So v cross b. So applying screw rule, we get the direction of the force along xy plane or at xy plane. So here we get r equals to mv square upon f. M is 1 given, v equals to root over 8 square plus 6 square whole square this divided by f equals to 20. So five. First equation, so we know clearly that the equation, the path will be maybe this, but this not, because this not, this path is at the xz plane. So, this is x-axis and this is z-axis. This plane is the xz plane. At this plane, the equation holds good. So this will not be the result. Our result may be this and maybe this. First we take that this one is right one because x square plus y square, which is a circle, taking the origin at the x-axis, taking the origin at the origin, we get the equation of circle of radius 5 unit. We get x square plus y square equal to 25. So answer B is correct one. Now we find the for A answer will be right or wrong. So this one also of the form x minus h whole square plus y minus k whole square equals r square at the coordinate geometry. At class 12 we have studied where hk is the center of the circle and r is the radius of the circle. So here center is twice 0, 2, 0 and radius equals to 5. So this one also holds good. Now the time period. For time period we get t equals to twice pi r upon v equals to twice pi r equals to 5. This divided v equals to 10 equals to 5 pi s. So this one also right. So answer A, B and D. These are the answers. Here is a problem which is based on the, suppose this circular wire. This is circular wire, a current flowing into this direction. So we have to find the magnetic field at the center of this circular conductor. Using Biot-Savart's law, we get B equals to mu 0 upon 4 pi I sigma. Suppose this is a delta L, this is R vector, this is delta L vector. So the angle which is tangent to the circle at that point, so angle 90 degrees, so sine 90 this divided by r square equals to mu 0 upon 4 pi I sigma delta equals to twice pi r sine 90 equals to 1, this divided by r square equals to mu 0 I upon 2 r. So B equals to mu 0 I upon 2 r. It will be applied here. So here this angle, what is this angle? theta. So theta, so delta L, here delta L will be A, here delta L, this one is delta L, we know বাংলায় বলে চাপ equals to ব্যাসার্ধ into কেন্দ্রীয় কোণ, বাংলায় এটা লেখা আছে in English, in English this one is sector is equal to radius into the central angle. So delta L equals to A times, what is this theta? So theta equals to this is pi by 2, this is 3 pi by 2 equals to A into 3 pi by 2, because pi by 2 pi 3 pi by 2. Total angle is twice pi equals to 4 pi by 2. So pi by 2 out, so 3 pi by 2. So here it will be mu 0 I upon twice A mu 0 by 4 pi I A into 3 pi by 2 this divided by A square. Three mu 0 I upon 8A. So for this portion A to C, we obtained the magnetic field at point O, but the current flowing through this also, through this also. For CO portion, the magnetic field at center will be 0, because delta L and R are at the same line, making an angle 0 degree to each other. So there will be sine 0. Also for this case, OA, there also will be sine 0 equals 0. So the answer only for ABC portion, which is 3 mu 0 I upon 8A. So answer D. The magnetic field, number 6 problem. We have supply of 6 problem. Problem number 6. The magnetic field due to a current carrying circular loop. The magnetic field due to a current carrying circular loop of radius 3 cm at a distance 4 cm at its axis is 54 microtesla. 54 microtesla. The magnetic field at the center of the loop will be this. So there are 4 answers. We have taken the relation by which the problem will be killed. The relation equals to B equals to mu 0 upon 4 pi mu 0 I upon 2 R square plus X square R square, where X is the distance suppose this point P, this point O. This is the case. There is a current flowing I to this. It is of radius R. It is of x distance. X equal to 4 centimeter given. Here R equals to 3 cm given. So we know B at P equals to mu 0 I 3 into 10 to the power minus 2 whole square. This divided by 2. This one equals to mu 0 I 3 centimeter and 4 centimeter are converted into meter unit. So this divided by 2 here B given as 54 into 10 to the power minus 6 Tesla. All of the units are in the SI system equals to mu 0 I into so from this two we get at the center x equal 0, put x equal 0, here we get B at the center equals to put mu 0 I value there, representing to 10 to the power minus 6 and 3 into at center this will be x is 0, so here R cube obtained, here R square, so 2R. Mu 0 I R square, this is by 2 R cube. Mu 0 I upon 2R equals to this is by 2 into equals to, so answer A. It was said that the previous problem was solved by the relation b equals to mu 0 I r square this divided by 2 whole into r square plus x square whole to the power 3 upon 2. আমরা বলেছিলাম এটা এখন থিওরিটা সলভ করব এখানে। It's very simple and let us proceed to solve the problem. Suppose there is circular current carrying coil. I is the current, this is center. Suppose this is O point, this is P point. Take here a delta L segment. Suppose this one is theta. So applying Barks-Sever's law, for this portion delta L at the point P we get delta B equals to mu 0 upon 4 pi I delta L upon, suppose this is D, upon PD square. Here is angle, this delta L, the tangent, the direction of the delta L is the tangent at that point on the circular loop, and to this line of DP, the angle made at any point on the delta L portion. When this one is added, then there is angle 90 degree. You may consider it. So sin 90 degree equals to mu 0 I upon 4 pi delta L upon PD square. What is PD square? PD square means mu 0 I delta L, this divided by 4 pi, this is R and this is X. So we can write R square plus X square. Now, the circular coil, this is circular coil, at input delta L, there is a, suppose in the vectorial notation, if we go into vectorial notation, we get mu 0 by 4 pi I delta L cross R, this divided by R modulus cube. Here delta L cross R, this is delta L and this is cross R. So we get a vector which is both perpendicular to this vector and also delta L vector. So this one is the, suppose this one is at this direction P K. Again I am saying PK is perpendicular to this vector, also perpendicular to delta L vector. PK is not at the both. This is a three-dimensional case. Suppose here is a delta L, again I am saying, and here is a axis. So when this goes, suppose this is circle, suppose circle this in this way, in this case. So this is delta L and this is R. So we get, when we get the direction, so another plane. So del B, when it is resolved into two parts, then we get if theta, then this also theta, because this line and this line perpendicular, also this line and this angle made by the two lines, and this angle also made by the that perpendicular two lines. This angle theta made by the two lines, this angle also made by the perpendicular of the two lines. So this one will also be theta. So if this theta, then this will be del v sin theta, and this will be del v cos theta. Similar case for delta L at the point D C. At point C we get similar case we get to here also. Similar case we get in this way delta B. So we get also here delta B cos theta, which is vanished out. So resultant magnetic field at point P for this delta L section, equals to delta V sin theta at for total coil equals to sigma delta V sin theta. So we get resultant EB equals to sigma delta V equals to mu 0 I delta L this divided by 4 pi r square plus x square. Now sin theta, what is sin theta? Sin theta equal to r upon this vector, r upon this PD length. So r upon PD length means root over r square plus x square. So mu 0 I upon 4 pi r square plus x square whole to the power 3 upon 2 into sigma delta L equals to twice pi r. Sigma delta L equals to twice pi r. All the remaining others are not dependent upon the sigma sign. So twice pi r. Ultimately we get mu 0 I so this one was applied there to get the problem killed at the previous one. A non-conducting ring containing charge Q. A non-conducting ring containing charge Q is rotated about its axis with an angular velocity omega. The radius of the ring is r. And a uniform magnetic field B exists perpendicular to the axis. Then the torque on the ring is 4 options given. The problem will be solved in a easiest process. What is the steps? First we find the current in the coil. What is that current? Q by T. Q charge is rotating, so Q by T means time period. we can get the current. Then we have to find the magnetic moment, which is IA. I is the current, A is the area of the circular non-conducting ring. After that, torque tau equals to M cross B, where M is the magnetic moment and B is given here, which is perpendicular to each other. So the torque will be mb sin theta into I. mb sin theta into I, mb sin theta into a unit vector which is both perpendicular to M and B. In this way, we can find the answer in a 1 minute only. So answer C. Same type of problem, but not the same one. A non-conducting annular disc of inner radius capital R and outer radius twice R. Contains uniform surface charge density sigma. The disc is rotating about its axis with an angular velocity omega. The magnetic moment of the disc. এখানে হচ্ছে কি ডিস্কটা টোটালটা ভরাট নয়, অ্যানুলার অর্থাৎ বলয়াকৃতি, যেখানে ইনার রেডিয়াস অর্থাৎ ভিতরের ব্যাসার্ধ ক্যাপিটাল আর এবং বাইরের ব্যাসার্ধ টোয়াইস আর। চার্জ সারফেস ডেন্সিটি তলমাত্রিক ঘনত্ব, সারফেস ডেন্সিটি অফ চার্জ গিভেন হিয়ার, সারফেস চার্জ ডেন্সিটি। আধানের তলমাত্রিক ঘনত্ব, বাংলায় বলে আধানের তলমাত্রিক ঘনত্ব সিগমা দেওয়া আছে। আমাদের কি বার করতে হবে? চৌম্বক ভ্রামক বার করতে হবে। এখানে আমরা ক্যালকুলাসের সাহায্য নিয়ে অঙ্কটা খুব সহজেই করে ফেলবো। কিভাবে? স্টেপ 1 হচ্ছে গিয়ে একটা অ্যানুলার রিং, in between capital R and twice R there is an annular ring is taken, or an elementary annular ring is taken for calculus notation of with dr, elementary with dr. For that ring we shall find the current. Also, when this current is multiplied by the area of the annular ring, we get the magnetic moment of that annular ring. And integrating from r to twice r, we get for the total magnetic moment for the total annular disks. Here is a point to be noted. The annular ring, magnetic moment of that annular ring, that it is a vector quantity. Its direction is the direction of a surface, that is surface vector. Suppose this is surface. What is its vector? Its vector is this. So, for each and every annular ring, the direction becomes the same. So that the total magnetic moment will be the summation of that annular rings. By integrating, we obtain the result. Suppose this is R and this is twice R. This is the total angular ring. This is the total angular ring which is sketched now. Suppose here is an annular section is taken which is of with dr, and this one is, suppose this one is smaller and this one is r plus dr. So the charge present dq equals to the surface area charge present, because sigma into twice pi r dr, because twice pi r dr is the area of the annular section in between r plus dr and r, which is equal to pi r plus dr whole square minus pi r square. You know it. We should not go further in details because you know it. Pi r square plus dr square plus twice r dr minus r square equals to twice pi r dr. Dr square can be neglected. You know it. So this is the charge present at the annular ring. Now current present equals to dq upon t equals to dq upon twice pi by omega, where omega is the angular velocity. So after we get omega dq twice omega dq upon twice pi. which is equals to twice by r twice by sigma omega twice by sigma omega twice by sigma omega r dr into twice pi by twice pi equals to omega sigma r dr. It is the, what is this? This is the current at that angular section. Now or the magnetic moment of that angular section dm equals to omega sigma r dr into pi r square. This area to be taken pi r square. So capital M equals to integrating r equals to r2, r equals to twice r, we get omega sigma pi omega sigma r cube dr equals to pi omega sigma by 4 equals to pi omega sigma by 4 equals to 15 by 4 omega sigma pi r to the power 4. So answer A. A cylindrical cavity of diameter twice A as shown in the figure. A cylindrical cavity of diameter twice A as shown in the figure. A cylindrical cavity of diameter A a cylindrical cavity of A of diameter A exists inside a cylinder of diameter twice A as shown in the figure. Both the cylinder and the cavity are infinitely long. A uniform current density J flows through the along the length. If the magnitude of the magnetic field at the point P, here is the point P, is given by this, then the value of M is this. So this is this problem is based on Ampere's circuital law. বাংলায় বলে অ্যাম্পিয়ারের বদ্ধপথ বর্তনী সূত্র। Ampere's circuital law. What this law says? This law says mathematically B dot dl integral line integral B dot dl equals to mu 0 I. What is that? Suppose this is circuit in which these are the currents. Suppose this one is current I1, this one is current I2. So, circuit law says I1 plus I2 in this way, where L is the total line. This line equals to, if the radius is A, then dl equals to B into twice pi A equals to mu 0 I1 plus I2. So applying this, we get for P when no cavity, then B at P will be obtained as B dot twice pi A. This is circle of length twice pi A. Length, this one is length. If B is add out for constant value, then you can get line integral dl equals to twice pi A equals to mu 0 pi square J. J is the current density. So pi square is the area. We get this. From this we get B equals to pi out mu 0 Aj upon 2. When for solid material at the cavity, then B dash at P, B dash at P will be obtained as B dash equals to, here is A and here is A by 2. So A into A by 2, that is thrice A plus A by 2. This length thrice A by 2. So for P thrice A by 2 equals to mu 0 pi A by 2 whole square into J. So B dash equal to this for line integral this, and we get B dash at P as this. If there is a point P here, then we have to circling this length touching P. So here is a P circling this length touching P, you get thrice A by 2 as the radius of the circular coil. So after all we can obtain, so B, resultant B equals to B minus B dash equals to mu 0 Aj upon 2 minus So when this one is comparing to this one, we get mu 0, we get n as equal to 5. So answer A. This problem is a very interesting problem. Here two concentric coplanar loops as shown in the figure diagram. So last of all, you have to find the torque on the smaller loop. So how to solve this problem? Here is I current, so at the center O, what will be the magnetic field? We have to find first that. Then M, magnetic moment for the smaller loop. We know magnetic moment for the smaller loop as I into A. Here is I2 into pi r square, pi small r square. So that M is the vector quantity and that B also vector quantity. What is the direction of B? B is the direction for circular coil. We know if a current carrying coil is a current I, so at B, suppose this is a delta L length, so this is R vector, this is a delta L vector, so delta L cross R, that is the into the plane of the board. So direction of B is the along the perpendicular to the board. Perpendicular to the board going inward, going inwards. And what is the direction of M? M equals to I into pi r square and its surface also this, because the any surface vector, any surface has the vector, surface vector, area vector, I a vector. Why the area vector? Area vector has a direction which is perpendicular to the surface. So M and B, M cross B will be MB sine 0 degree into torque tau MB which 1 equals to 0. So the answer D. Because B is also B equals to mu 0 I upon twice R. So B can be obtained by delta V by Bart's law, mu 0 by 4 pi into sigma delta L sine of 90 degrees divided by this length is r square, so mu 0 by 4 pi into twice pi r, this divided by r square equals to mu 0 I by twice r. So this one comes from this, so answer D. This problem, electrons are accelerated in an electron gun through a potential difference V and are ejected from the gun towards GA. A magnetic field B exists along GP making an angle of 60 degree with JA. The minimum value of V for which the electrons hit a target at point P is this four answers given here. Where mass of electron given, charge E and Gp equals to D given. Here is the problem. So electron velocity, electron is coming out from this target, along this direction, G direction, and now so along this direction, V, the velocity V, then along this V cos 60 degree. Now the electron comes from here into this direction, going into in this way. So this is a case of helical path for which P equals to twice pi m V cos 60 degree, this divided by Q B equals to twice pi m V half upon QD. Now, so P should be the GP length D. So D, here the helical path. This is the helical path. So this is the total pitch, which is equals to RD. To get the total path pitch, and it will maximum when it is maximum for D equals to twice R is the radius. Here not the case here. So D equals to twice pi m upon QB. Pi QB and V equals root over twice EV by m, because half mv square equals to EV. When the electrons comes out, then half mv square equals to EV, where V is velocity, sorry, V is the whole potential difference. So from which we get this equals to Q means here, Q means E, EB, here Q means E. So we have to find the minimum value of V. So D equals to pi E. So pi root m root 2 root V upon root E D. So squaring, we get d square equals to pi square 2 pi square mv upon b square E, implies V equals to d square E upon twice pi square m. So answer C.